Let's do a hypothesis test about averages. So this is going to be remarkably similar to hypothesis test about proportions, but we just use the standard deviation of averages, and we use t-scores instead of z-scores. The average human body temperature is believed to be 98.6. That sounds like a claim to me. We have 106 people with an average body temperature of 98.2, so this is our study, and the standard deviation of our sample is 0.32 degrees Fahrenheit. Perform a hypothesis test on the believed body temperature using a probability threshold of 5%. So the believed temperature, it's believed to be 98.6. So our null hypothesis will be matching the claim that the average body temperature is 98.6, which means the alternative will be that the average is not equal to 98.6. We want to use a probability threshold of 5%. We have an average from a sample of 98.2 and a standard deviation of our sample of 0.32. Okay, so let's draw the distribution of critical values. So t-scores. I'm using a probability threshold of 5%, but my alternative is not equal to. So it would be significant if I was on the left or the right-hand side. So I need to take that 5% and I need to split it up. We'll put 2.5 in that tail, and we'll put 2.5 in this tail, leaving us with 95% in the middle. Let's figure out what these values are, these cutoff values. So I'm looking for the t-value that matches this picture. Not z-scores, but t-scores. So look at that picture that you have drawn. You're looking for the t-score that has 2.5% in one tail. So right here. And let's just double check. If you have 2.5% in one of the tails, then that's 5% in both of the tails. And that positive t-value has 97.5% of the area to the left of it. So I'm somewhere in this column. Now we need to go down the column. Our degrees of freedom, remember, it's one less than your sample size. So our sample size, do I have that written down? No, I don't. N was 106 people. So we're looking for a degrees of freedom of 105. But I see that I don't exactly have 105 here. So we're just going to estimate with the closest value, 100. So the t-value that we're looking for is 1.984. 1.984, and by symmetry, minus 1.984. All right, our picture, we center our distribution at the null hypothesis. And our sample value is 98.2, so it's somewhere over here to the left. Let's figure out how far. Is it inside that tail, or is it not inside that tail? So let's compute a t-score. T-score will be the average from our sample minus the center average divided by standard deviation. So because we're dealing with averages, remember to use the standard deviation of averages given to us by the central limit theorem. The sample standard deviation divided by the square root of n. All right, our sample average, 98.2. The center average, 98.6. Our sample standard deviation, 0.32. And we divide that by the square root of n, 106. All right, when the algebra clears, we find a t-value of minus 12.87. So not only is that further than minus 1.984, it's way over here. So it's definitely in that reject region. So the conclusion will be to reject the null hypothesis that the average human body temperature is 98.6. Probably it's a lot less than 98.6, at least a lot in terms of this standard deviation or the spread of this distribution. Right, you got something remarkably surprising. So reject your null hypothesis because your value is inside the tail of your distribution.